Hello everyone again. Thank you. So, in case some of you fell asleep like 1 hour ago when I was ending the previous presentation here, so no, I'm back again. Now you can stay awake. Thank you. This session is going to be about making something that is like a table in HTML, though more awesome. My name is Leif. I work at the Vaadin team as a product manager. I also, like 17 months ago, I got a unofficial title of Grid Master. I have been building or being in charge of building the grid widget that we are now really happy to finally have a final release of just any day now. The topics here will be quite much focused upon focused on performance, how to make your widgets so that they are performant, what kind of tricks can you use, what do you need to take into account, and generally using grid as a case for exploring these kind of ideas. The slides are online. I will also tweet a link to them as soon as I remember after this, so that you don't need to memorize what's on there. The structure here will be that I will start by showing how grid works in practice. I will code a small example with it. Then we will look at all the interesting technical details, and then at the end I will take all your really tricky questions on the topic. But let's go ahead with some actual coding. All right. So I now have just a really simple hello world. Yes, it's still there in the browser. So what I want to do is to use the grid widget. So let's get rid of this label. Instead, create a grid. Grid is typed to it generates to the row type. So in this example, I will use source files as the row type. Let's add it to the root panel. And then what we need to do to actually get something on the screen, first we need to give it some data, and then we need to configure at least one column. So getting some data, grid.set data source. I'll be slightly cheating, just use a list data source that just has all the data in memory on the client side. In real world, you would probably want to use a remote data source instead. And I'm also cheating a bit, so I'll just get a pre-created list of source file instances, and that semicolon should not be there. So now we had a bunch of rows for the grid. Then the last thing we need to do is to add a column. A new column. This is exactly the same structure as with GWT cell table. So what's going on here is that for each column you have a callback that extracts that column's value from a row object. So what happens here is that this getValue method, it gets a row, and then here I want to get the name, return that as a string. And actually I also want to find why I have a compile error. Oh, return. I'll also set the name of this to name. This is slightly small. Let's scroll. So refreshing, we get now this one column long list of just source file names. This is actually the client side names, or the client side Vaadin classes. The next thing we could do is to add a couple of more columns just to make this interesting. Now I copy-pasted, so I have 3 instances here. The first one would be integer typed, and the name is ID. We should return an integer, and what we return is row.getID, like this. And then the last one would also be an integer. And here we return the size of the file. Update the return type, and here get size. like this. Still really basic stuff. Can I find my browser again? There it is. So now we have ID column here to the left, and then if I scroll sideways a bit, I also find the size. Scrolling through this, one thing we notice is that this ID column is slightly too narrow. It's because like the width has been auto-detected based on the like initial data set, the first like 10 rows or so, and now it happened to be so that those were quite narrow, but then later on we will get wider rows. So that's something we need to like give a hint that, hey, could you please make it slightly wider? And then also one thing we want to add here is that if I like check out the sizes, I might, for some completely imagined reason, I might want to see the IDs all the time also. So let's make it so that those are always visible. So what we do is that we take the ID column, just put it into a variable. Then we can say ID col dot set width, and let's make it 50 pixels wide. The other thing we're going to do is to say to the grid that the leftmost column should be frozen. So set frozen column count, and then one column is frozen, like this. Now going back and refreshing, we see that now the ID column is slightly wider, so actually like 3-digit numbers also fit to it. And scrolling sideways, we have so that the ID column is all the time in view. Now let's make things a little bit more interesting. Let's add yet another column. What I want to do here is that I want to show the history statistics for this file. History here is a double array, and just return row.get history like this. So let's see what happens. Of course, what happens is that now we just get like each double array .toString run by the implementation, and that's not really what we wanted. What we really want here in this case is to show a small graph with that like historical data. To do that, we need to use something that we call a renderer. That's basically the same thing as a cell widget in cell table in GWT, but it has some additional cool features that we'll see right now. So let's start by actually creating. I want to create a sparklines renderer here. So new, thank you. Sparklines renderer, like this about, yeah. Let's create that class. I will not inherit the raw render interface, but instead I will use a widget renderer that lets me use any like GWT widget as the cell content. I will remove these because I will add some type information here. So the T here is the type of the rendered data, so that will be a double array. And then the widget is the actual widget type that we will be using. I have a convenient sparklines widget already on my class path in the module. So now we recreated those methods with type data. And what will happen here is that the grid implementation will create just enough widget instances to show one screen full of data. And then as we scroll to keep performance good, we'll reuse those instances, just like move them so that they are displayed in a different place, update the data of that widget instance, and then we are good to go. So this is a two-step process. First we have this create widget. Here we just create a sparklines instance, give it some parameters. Let's make it 200 pixels wide, 30 high. The minimum data, the like range of the data we will be showing is 0, and the maximum is 100. And let's return this one as well. So that's the create widget method, and then here in the render method, this is the one that actually updates the data. It gets the data for that cell, and it gets a widget instance that is like also corresponding to that cell. So all we need to do here is to take that widget, and this sparklines widget implementation has a set data method that takes a double array. So with this render implementation, saving this file as well, refreshing, didn't explode. So now here we have, it's not really visible there on the on the projector screen, but if you squint, you can see that, yeah, okay, there's actually like some spark lines there. So we can scroll through these, and everything is just the way we expect it to be. Let's add some more features here. I will continue with really silly examples, just so you don't get any ideas that this would be useful in real life, though it is. Grid, I want to add more headers. We had one row of headers there, now just showing the column names. Let's prepend, not a footer row, prepend, thank you. Prepend a header row, so we add additional row on top of the pre-existing one. Actually, to use it, or to say where I put data, I need the column instances. So this was the name call. This is the size call. And this then is the history call. So yeah, continuing with silly examples, row get cell, so get a cell in that header row corresponding to one specific column. Let's pick the name column. And then what I can do is that I can set content as plain text, HTML, or I can put more GWT widgets there. So let's put a really convenient widget here, set widget, new button, I'm a button. And then also another cool thing we can do here is that you can combine multiple like columns into one. So row.join, what I want to join is the size column, size call, and the history. And then I get a cell for that, and here we'll just set the text to something like I'm joined. Like this, going back to the browser and refreshing. Now we see, okay, here's the button. You most usually wouldn't want to put buttons there, but one quite good use case is that you had like text field for live filtering, so that you can like input your search criteria there, and then it filters on the fly if you implement it that way. And then we also see here that I'm joined, which is then like going over two columns. The last thing I will demo is, let's make this grid slightly wider. Set width, let's make it 900 px. That's about what will fit on this resolution, I think. Yep. So what has happened now is that we don't have any scrolling sideways anymore. All the extra space has now been divided. Okay, the ID column has like fixed 50 px width. All the others have received like a couple of extra pixels. That's not really good for this history column because it's really like should have the same width as the sparklines widget has. Otherwise, it looks kind of silly. That one we can fix by doing history column set expand ratio 0. So then it won't expand. If you look at what we have now, yeah, then we have no white space there. And then actually, if someone would be like UI designer or something, look at this, he might say that, hey, it's like hard to read because it's like so much white space between the size and the rest there. So let's reduce the size of this one. It's okay that it's not really cramped, but we don't want to have like lots of white space. So let's just put a max size on that one. So size call, set max width, and here maybe 90 pixels would be good. Actually, let's reduce it a little bit more, maybe 70. Like this. So now there's a little like, it lives a little, it expands if there's extra room, but most of the extra room actually goes here to the like main column, the name in this case, because some of these have really long names, so this one doesn't really fit still. So that's a short preview of what kind of stuff this grid thing that we will be focusing on can actually do. Actually, I will jump out of that and turn back mirroring, and then back to the presentation. Yeah, so that was the demo. Now, let's have a look at all the technical stuff that goes on behind that demo. The things we'll be covering is like how to get it to scroll smoothly, even on like slower mobile devices, even if you have lots of columns, lots of rows. Have a short look at what it takes to get scrolling to work nicely, in this case on touch devices, because that requires some quite interesting things that you might bump into in your own projects. Lazy loading is also kind of exciting because it's really like lots of things you need to take into account to actually get a smooth experience. And then at the end, the last technical detail I'll drill into is this really interesting thing that goes on if you give the browser lots of rows saying that, hey, actually the limit is like around 10 million pixels. At that point, things will start to break down in interesting ways, and we need to have interesting workarounds that are also useful in other cases. So that's about that. One sad part here is that all these used to be like standard, at least for me, standard questions when interviewing guys wanting to work at Vaadin. So now soon these will be on YouTube and I would have to find some other questions. So what goes on when we scroll? Everything starts in the browser, the document object model, all the elements going on there. It fires an event saying that, hey, scroll position has moved because something. In our implementation, Grid itself doesn't talk directly with the browser. Instead, we have this thing that we call escalator that is really like a low-level thing that just takes care of talking with the browser. What happens? Escalator sees as, hey, okay, someone scrolled, now row number 15 also came visible. All right, what should we do? Escalator doesn't know anything about almost anything except the elements in the DOM. But hey, it knows I can ask Grid to handle this. So it said, hey, please Grid, row 15, here's the elements you should put the data into. Could you handle this? Grid says, well, okay, I don't really know anything about the data and not really what to do with the elements either, but I know the data source. It can give me the actual like source file object or whatever you have corresponding to row 15. So okay, Grid gets that from the data source. Grid still doesn't know what to do with it. Luckily it knows that, hey, I can ask my column instances, hey, here's the row object, here's the element for this row in this column. Could you please do something about that? Column still doesn't have the entire picture. What it can do is that it can take that specific value that should go into the cell, extract it, and then it also has the element, doesn't know what to do with them, but it can pass them on to the renderer, like the Sparkline renderer, for instance, that we just saw. That one then gets the data should be in the cell, get the element where the cell content should be, it puts it there in some way, and then actually we have the circle is completed. We have scrolled a little bit, updated the value into the DOM. Looking even more detailed on the scrolling, so it's really lots of tricks going on here to get it really as smooth as it just can possibly be. So what's going on? Here we have really small viewport, just like a couple of rows visible, just to make this as simple as possible. What's going on is that, okay, we scroll a bit. What happens is that like things inside the box kind of move around. What actually happens though is that like we would have all the elements there just like moving then, and then we just peek through that little hole and then we see those rows. This is, however, not really efficient because then we would like allocate lots of memory for all like row elements in the DOM. So what you really want to do is to only keep the rows that are visible in the actual DOM structure. Everything else is just like data source keeps track of them, but we don't have any element instances allocated. Now we scroll up a little bit, just a teeny tiny bit. Now we realize that, hey, row 2, it's not needed anymore. We don't see it. So what we can do then is that, yeah, let's get rid of that one as well. We'll be really lean here. The other approach would be that we like collect a backlog. We like let it scroll until we have, say, 10 rows that are not needed anymore, and then we get rid of those. The drawback here is that then things will be mostly smooth, but then at some point it will freeze up for a little while and then continue scrolling. So instead, by like doing as little as possible, but often. Then we get like an overall smooth picture without any like long pauses. But let's continue scrolling a bit more. Now we got to really the edge, like now row 6 would be needed. So okay, let's create row 6, put the data in it. Now we can continue scrolling like this. And now actually we can detect one more thing that we are doing that is really like waste of resources. Because now we have been like destroying one element and creating another one. What we instead could do is that we reuse the same element, DOM element instance, instead of creating and destroying it. So in that way, for instance, the garbage collector will be much more happy. So what we do is that we take the row 3, move it so that it's like in the position in the DOM where row 7 would be, and then we update the contents of it. Right? Continue scrolling a bit. But we can do even better than this, because when we like change the order in the DOM, then the browser again needs to reevaluate lots of things. For instance, like if you have a first child CSS selector, the browser needs to update that one, and lots of different things that like cascade just from taking this element and putting it at a different child index. So instead, what we can also do, that's even better, is that we take the row, we leave it at that place like in the DOM order. We just visually move it so that it's still there like according to the DOM, but visually on the screen it's like a corresponding amount of pixels further down. So in that way we can now like keep scrolling and just like reusing the same elements going around and around and around, and that's from where the like escalator name comes. Oh, we had even one more scroll step. Then we can go on. Now, the cool thing, the obvious way of like how you visually move those elements is to use CSS changelab top attribute, standard absolute positioning. This is quite good. This is what we need to do in all the browsers, but we can do better. Because when you update the like top attribute, for instance, then things still change in the browser. For instance, like if you read the like offset position of that element, that's something that the browser needs to like see that, okay, we have a top attribute defined in CSS, so we should read it from there. So this is actually like, it's quite good, but it's not the best we can do. What we instead can do is that we use translation. These are completely like in the CSS specification defined that these are only visible. They have no side effects that can be observable from JavaScript. So that means that here the browser can actually like, it can instruct the GPU that, hey, this is one like bitmap that we will be moving around. So when that attribute changes, when that Y changes there, browser doesn't do anything else than say to the GPU that, hey, this bitmap that you already have in your memory, just could you put it at these coordinates instead of wherever they were before? And in that way, we can actually like, on modern platforms, this is really like hardware accelerated, so there's almost no CPU usage at all, and the GPU is really optimized for doing this lots of times per second. One small gotcha here, this works really well in supported browsers. The other browsers then can use, for instance, the absolute positioning instead. But this is semantically wrong, because here we're saying translate 3D, which is what is needed to get this like reusing the bitmap in the GPU thing happening. But we don't really want to do any 3D stuff. We are just moving in 2D. So eventually, I think Chrome already has this, or actually Blink already has this, so Chrome and Opera. Other browsers will probably introduce it. It's a new CSS attribute that says will change. And then we'd like tell the browser that, hey, this is something that you should be prepared to animate. So here we say that like transform is something that the browser should be prepared to do something with. And then the browser can intelligently see that, okay, we have enough resources in the GPU, memory buffer, and so on. And therefore it chooses, it will actually do it so that it's hardware accelerated in the same way, even though we use the regular like 2D transform and not the 3D one. So doing this for the scrolling, everything is really nice until you stop scrolling, because then you would have all the elements like in some, okay, not completely random order, but they would be jumbled up, and that makes, for instance, like tabbing through the content really complicated. It makes screen readers like assistive devices also get upset by this. So what we need to do is that once the user has actually stopped scrolling, at that point, we need to like put the order back again. All is fine, except that when we rearrange elements in the DOM, then like if we move the element, if some element has focus right now, keyboard focus, then if we move that one, it will be detached and attached slightly later on, and that actually causes the focus to be lost and scroll position to be forgotten inside that element and those kinds of things. So also here we need to be careful to like take the, if there's a focused element, we keep that one in place and just move all the others around it. Next big topic, touch scrolling. So you have your touch device, let's say it's an iPad or something, you scroll around it, you notice that, oh, we don't have any like flick scrolling, so that it follows my finger good, but I can't get it to like move quickly just by like flicking it away. What you can do, you set this really standard or conventional, everybody uses it, CSS attribute, WebKit overflow scrolling touch, and then all the like browsers will actually give you also flick scrolling, and things will behave just like natively. The problem with this is that now suddenly we don't get any scroll events until the actual like flick movement has stopped. So it starts moving, it moves and moves and moves, and it stops, and at that point the browser tells the JavaScript that, hey, scrolling has happened. And because we want to, like, for every new row that gets visible, we want to get an event saying that, hey, now we should update the contents of that row. So therefore, this is not good enough. It's not usable at all. The good news is that this was like a performance feature of iOS, because you can really kill performance if you do things, if you do complex things each time you get a scroll event. So therefore, they chose like from the beginning of iOS to not give you events all the time. This has changed in iOS 8, and it also works the way you would want in Android. But if you want to support like iOS 7 or older, you need to do things in a completely different way. So what you need to do is to actually like manually take all those touch events and translate that into doing scrolling yourself. This is like a slightly simplified example of what the code would look like for that. One thing you should also remember to do is to, for all those touch events that you handle, you do prevent default and stop propagation, because otherwise the browser will like also emulate a click event for you, because it's once again like backwards compatibility, so that non-touch aware JavaScript with just click listeners still work. So you need to cancel those events to tell the browser that, yes, I'm taking care of touch, or I support touch events. You don't need to emulate any click events for me. Actually, looking at the scrolling, the first things that happens is you get a touch start event. Then when the finger like starts touching the surface of the screen, at that point, one thing we need to do is that if we have a flick movement going on, then it should stop immediately. The other thing we do is that we just record like where was the finger when this started. Actually, another thing we do is to check that it's only one finger, because if you have multiple fingers on the screen, then you don't want to do scrolling, then you want to do something else instead. Then when you have the finger there and move it, then you get a touch event, a touch move event, I mean. Here we just like move the scroll position based on where the finger is now, like compared to the original position. And then the last thing, when the finger is released, then we see that if it was like moving while it was released, basically like if the release position is different than the previous known position, then we like calculate how quickly it moves and then do a flick animation based on that. Next, let's look at the actual what happens when we get a touch move event, because that move by event, it's not really straightforward. The problem is that we might get many touch move events basically at the same time, and it's really inefficient if you do all the calculations all the times. So instead, we use this thing that GWT provides, animation scheduler. It maps directly to native request animation frame functionality that all modern browsers have, and it can be faked for older browsers. So what this does is that you just tell the browser that, hey, could you give me a call back the next time you are just about to update what's actually on the screen? And at that point, we can then see that, okay, now the last known finger position is this, so that means that's how we should update the scrolling. So in that way, we only update the scrolling, we only do the calculations and the DOM updates when the browser is actually about to do something sensible with that data. So what we do in practice, move by event, we just record that this was the last event we got, so we know where we are, and then we say to the browser that, hey, call this mover callback when you're actually will be needing to know where elements are. And as a small optimization, we can also pass an element to this method. It helps the browser optimize so that if that element is not visible on the screen, then it will not use resources for animating it as often. It's still once per second or something like that, but not 60 times per second. And then in the actual animation callback, we record the timestamp, when was the last move. We need this later on, and then we do the actual updating of scrolling only here, because in that way we don't do it if it will not be used by the browser. So that was that. Then the actual flicking, so when the user lets go, releases or stops touching the screen, then the only thing we do is that we again say that, hey, now we will start doing animation. Then in the actual animation, we compare timestamps. This is slightly tricky. You might need to watch out for this with older browsers. This timestamp that you get, the specification says that it's a floating point timestamp based on the time since the page was loaded. Older implementations actually give you a standard Unix timestamp instead. So the resolution is the same, but they are completely different magnitude. So you need to be slightly careful that only compare timestamps that you get to animation callback method to other timestamps, not to any other values that you get system current time as millis or something like that. But still, what we do is that we see what's the time now, when did this animation start, and then from that we see that, okay, we are this long into the animation. Then if this was the first animation frame we got, we also calculate the initial speed based on when was the last movement and how much did we move previously and how long ago was that. And from that we have an initial speed, and then given the initial speed and the time we are at right now, it's just like high school physics to get that with also a deceleration to get into where will we be right now. And the last thing we do is that we see that, okay, if the deceleration has gone so far that we are not moving anymore, then we stop. But if we are still moving, then we are saying that, okay, call back again next time you're ready to draw a frame on the screen. So that's what you might need to do if you need to support older than iOS 8 devices and want to have scrolling so that you actually all the time know where the scroll position is, instead of just getting an event when the actual scroll movement has stopped. The next thing we will be looking at is lazy loading of this data. So this is basically what do we need to do at the at this data source, interface between grid and data source to sensibly support like lazy loading of anything. Just a reminder that previously this scrolling thing was handled by escalator because it's really low-level stuff. Here now this is more like high-level stuff. It's grid that is in charge here. So let's begin with something really simple. Abstract remote data source, that's just like anything that fetches data from some remote location asynchronously. This class also will do other things for you, but like this get row is something that you would need to actually implement. You're supposed to fetch data from the network, so instead of like returning the value immediately, you get a callback that you can call when you have received a response from the server. And that's about it. One problem here with this really, really simplistic solution is that we just ask for one row at a time. What if the row is already loaded? What if we might want to fetch like several rows at once so we don't need to hit the network for each individual row? We have no good way of knowing how many rows to fetch with this simple API. So let's make it slightly more complex. Now we like make the get row. That's something that the implementation takes care of for you. You need to only do the request rows. So now you just need to implement this, and it's the like data source implementation that worries about like how many rows should be fetched, where should we start, what should we do with them. So then you instead have like a slightly different method you implement, where you have like the start position and the number, or start index and the number of rows to fetch, and of course the callback. This is better. It's still not optimal because still the data source implementation, like the superclass, it can't really know how much rows it should ask to fetch because it doesn't know anything else that, hey, now he asked for row 15. Should I check row 17 as well? Maybe, maybe not. It knows what it has like in its own cache memory, but that's all. So we need to add one more concept, some way of telling the like implementation that these are the actual visible rows, because now we can see like okay, these are at least the ones who will be needed, and then we can have some kind of caching strategy saying, for instance that okay, we should always have at least 3 pages full of rows already loaded, but no more than 5. So if we have more than 5 because we have scrolled past that like those indices, then we can discard them from the cache, and whenever we are starting to approach the limit of what we have, then we can easily calculate that, okay, we will need this many rows, all is fine. One last thing here that you also would want to avoid, even with this, if you scroll really quickly, so that you are way past the requested indices before the response has arrived, then you should not keep sending new and new and new requests, because then you would if the user scrolls quickly, you could suddenly have like hundreds of requests all waiting for a response, and all those bytes would need to get over the network until you can get to the rows that you actually want to show right now. So instead, this like abstract remote data source should also take care of only requesting more rows, actually like calling this request rows for you, when it has seen that, okay, I got a response, do I need more rows? If it doesn't need more rows, then everything is fine. If you have scrolled since the last request, then it sees that, okay, now we need these rows instead, and then it can immediately ask for those instead. So that was some things with lazy loading. It's not really rocket surgery, but quite there. Pixel limits. Oh yeah, this is really fun. As I was saying in the beginning, browsers don't like to have like lots of rows, because around 10 million pixels, it depends on the browser, but it's really interesting that it's so close. The like best browsers manage 40 million pixels, the worst ones 10 million pixels, so it's quite tight range there. I would like have expected, let's say Chrome is good, so Chrome should handle at least 1 billion, but that's not the case. Actually, what happens is that like inside the scrollable area, we still need to allocate all those pixels to get the scroll bar to like have the right proportions. But we can't do that because if you scroll beyond like 10 million pixels, then most browsers will only show like empty there. Even though you have like said that yes, there is an element there, show it, but the browser just, it doesn't know what to do with those big numbers, so it's just empty there. Other browsers also could actually also in some cases look up. I won't embarrass any browser vendors by telling which one. You might think that 10 million pixels, that's plenty. And okay, you have like 20 pixel rows, you can still get like 500,000 in there. You might not want to like have the user scroll through that many rows. Instead, you should probably do some like UX design and add filtering or grouping or something like that. There are still cases. One is actually like scrolling through log files might be sensible maybe. One other thing that I personally have like discovered is that what if we don't have like one row of text in the row, but instead like higher rows. So the case that I have is I'm making like a kind of like iPhoto, so you have like lots of thumbnails that you can scroll through smoothly, and then you can open individual files. That way you could have like, say, 250 pixel rows. And then, okay, you could like put several thumbnails in different columns, say 5 thumbs per row, but that only gives you like 200,000 thumbnails, and that's not really much. I mean, I've been abusing DSLR for about 10 years, and I'm at about 150,000, so it's really like a realistic limit, this, or it's a real problem. The thing we need to do about this, if we want to have those scroll bars to show in proportion to like what data we have there, those scroll bars can't be like directly connected to the scroll thing. Instead, we need to have them like detached so that basically we can have a like ratio between what's actually scrolled and what the scroll bar thinks happens. So to detach these scroll bars, this is like what's inside the grid viewport. We just have a limited amount of rows because we don't keep them in the DOM, but then we have a bunch of columns as well. The first thing we do is that we actually like add the viewport. This one is with CSS said that, yeah, okay, there's scrolling going on inside it, but don't show any scroll bars. Instead, what we do is that we take these like fake scroll bars, put one on the side, one on the bottom, and then add some small fillers to the corners to make things look good. So with that, we can now actually like have this like kind of zoom ratio so that if the scroll bars is moved corresponding to like 100 pixels, we actually move like the data scroll position so that it would be as though we would have scrolled scroll bar 100 pixels, data 1000 pixels. So in that way we can like have more data there. We just need to like do some offsets inside the actual data, and then everything is cool. This technique is also usable for other cases. For instance, if you have ever looked at how Google Spreadsheets is implemented, it's all the same. Cell table also uses the same trick. How to do this? This is really simple. This would be like a normal scrolling thing. You have like the viewport and then a scroll bar on the edge. And then we just like shrink the content so it's just as wide as the scroll bar is displayed on the screen. One gotcha here is that on some systems it's 0 because like the scroll bars on OS X, for instance, only pop up when they are actually like used. Otherwise, you don't see them. So that needs some extra tricks. How do you know how wide the scroll bars are? That's quite easy. You first take an element, make sure there's scrolling in it, measure the like inner size of it. Then you say to the browser that, hey, don't scroll anything, measure the inner size again, and the difference is how big the scroll bars are. And with these scroll bars, we then like add scroll listeners to those, and whenever we get an event, we update correspondingly to the grid. And the CSS for this is really trivial. We have like outer div, it has overflow either Y or X, depending on which way we go. Width of it is just the native scroll bar. Width, height, okay, I have a typo there. Height is the like size of the like viewport. And then the inside, just a div with some styles. The width is again like the same as the outer div, and the height is actually like as big as we want to fake that the content is. So the amount of stuff we scroll through. That was all the technical details. I guess you are really eager to find out more about this, use it, try it out, check out the sources, everything. Sources are at GitHub/Vaadin/Vaadin. The class you actually would want to look at is this widgets/grid.java. It's just like 3, 4, 5, many million, no, 1,000 rows. It's not really scary at all. If you want to use it instead, we have this Vaadin widgets.jar. This is new thing that we are introducing with Vaadin 7.4, which comes any day now. It contains the grid widget so that you can just pop it into any project. It's like compatible directly with GWT 2.7 and probably newer as well. It has like standard theme, or then you can use your own custom theme as well. Maven coordinates are there if you want to get it that way. Otherwise, you can also get it from vaadin.com/download. To use it, you only need to like inherit Vaadin and inherit the standard Valo theme if you want to use it, or then you can add your own theme, even though you might want to look at what's there to get all the like low-level like scroll bar styles and that kind of stuff. All right. Last resource I have for you is this project in GitHub. This is a really like as simple as it can be example of doing a grid application in GWT. So it's just like what I've shown you, like the GWT XML file, and then like a couple of lines of Java for actually getting the grid on the screen and some data into it. So, in summary, you saw how grid works. We looked at like how to be really lean with reusing elements in the DOM, how to get GPU acceleration when you move things around on the screen, how to use request animation frame or the animation scheduler to not do work that will not end up on the screen. We looked at fake scroll bars, like how you can detach the scroll bars that are displayed from what's actually going on. And then finally, you got some pointers for where you should look if you want to use grid in your projects. So with that said, I'm open for questions.